Welcome to Universe Orbit, your gateway to exploring the vast wonders of space, where the mysteries of the cosmos unfold through captivating videos. Don't forget to subscribe so you never miss a single voyage through the infinite universe. The solar system is a vast, intricate, and astonishingly diverse neighborhood in the cosmos. When we think of the planets, moons, and the sun, we often imagine them as they appear in pictures. Planets evenly spaced, brightly colored, and easy to comprehend on a page or a screen. But reality is far more staggering. The solar system to scale is almost incomprehensible in its vastness, and truly grasping the relative sizes of planets and the distances between them can completely transform the way we perceive our place in the universe. At the center of this system burns the sun, a colossal ball of plasma whose gravity governs the motion of every object in orbit around it. Its diameter is about 1.39 million kilometers, making it more than 100 times wider than Earth. If the sun were hollow, over 1 million Earths could fit inside it. Its light and heat sustain life on our planet. But in terms of scale, even this massive star is just one among billions in the Milky Way galaxy. The sun's gravitational pull extends far beyond the planets we commonly think of, influencing comets in the Oort cloud at the edge of the solar system, hundreds of times further than Neptune, the outermost recognized planet. Close to the sun, the inner solar system features the terrestrial planets: Mercury, Venus, Earth, and Mars. Mercury, the smallest of these, is only slightly larger than our moon, yet it endures temperatures that swing dramatically from blistering heat to freezing cold due to its lack of atmosphere. Venus, similar in size to Earth, is shrouded in thick clouds of carbon dioxide and sulfuric acid, creating a runaway greenhouse effect hotter than Mercury's surface. Earth sits comfortably in the habitable zone, a delicate distance from the sun that allows liquid water to exist. Mars, the red planet, is about half the size of Earth and hosts the tallest volcano and the deepest canyon in the solar system. Yet it feels small and distant when compared to the immense voids between planets. The distances between these inner planets are vast when measured in kilometers, but minuscule in the cosmic scale. Mercury orbits the sun at about 58 million kilometers, Venus at roughly 108 million kilometers, Earth at 150 million kilometers, and Mars at 228 million kilometers. These distances are difficult to truly comprehend until you scale them down. For instance, if the sun were the size of a basketball, Earth would be the size of a small pea nearly 26 meters away, while Mars would be another 38 meters beyond that. Even in this scaled-down model, the distances are enormous relative to the objects themselves. The inner planets are compact in size, yet separated by great stretches of near-empty space. Beyond Mars lies the asteroid belt, a vast collection of rocky remnants from the early solar system. Although it contains millions of objects, the total mass of the belt is less than 1,000th of Earth's mass. The gaps between these asteroids are immense. Collisions are rare. This belt represents a sort of cosmic debris field, the leftovers of a failed planet that never formed due to Jupiter's strong gravitational influence. Jupiter, the giant of the solar system, dominates the outer planets. It is more than 11 times the diameter of Earth and over 300 times more massive. Its swirling bands of clouds, storms larger than our planet, an iconic great red spot make it a breathtaking object to observe. Yet even Jupiter, massive as it is, occupies only a tiny fraction of the distances involved. Saturn, equally majestic with its iconic rings, is about 1.4 billion kilometers from the sun. Uranus and Neptune, ice giants far beyond, orbit at 2.9 billion and 4.5 billion kilometers respectively. The vast emptiness between these giants dwarfs the planets themselves, emphasizing how tiny they are against the cosmic stage. If we try to imagine the planets to scale, the challenge becomes even more mind-blowing. The sun dwarfs even the largest planet, Jupiter, which could fit over 1,300 Earths inside it. Earth itself is just a tiny speck in this grand scale, smaller than Jupiter's many moons. The outer planets, though massive, are spread so far apart that the distances between them become the dominant feature of the solar system's architecture. Space is mostly empty. The planets, though visually impressive, are just islands in a sea of darkness. Moons add another layer of wonder. Jupiter has over 90 known moons, from tiny irregular shapes to massive worlds like Ganymede, larger than Mercury. Saturn's moon Titan boasts a thick atmosphere and lakes of liquid methane, while Enceladus sprays water ice from its south pole, hinting at a hidden ocean beneath its icy crust. These moons, each a unique world, are dwarfed by their parent planets, yet sometimes larger than Mercury, further emphasizing the disparity between sizes and distances in the solar system. When we push outward beyond Neptune, the scale grows even more extreme. The Kuiper Belt, a ring of icy bodies including Pluto, Haumea, and Makemake, extends from roughly 30 to 55 astronomical units, AU, from the Sun, where 1 AU equals the distance from Earth to the Sun. Even farther lies the Oort cloud, a theoretical spherical shell of icy bodies extending up to 100,000 AU. The space between stars in our galaxy is far greater, but even within our solar system, the vastness is staggering. Objects are minuscule points against incomprehensible distances. Visualizing this scale can be difficult. If we continue with the basketball sun analogy, Neptune would be over a kilometer away, Earth still a tiny pea, and Jupiter a small marble. Even if the basketball could somehow encompass the entirety of the inner solar system at a few meters in scale, the outer planets would stretch across city blocks, and the Oort cloud would disappear into the horizon. Our familiar conception of the solar system as a compact, orderly arrangement is completely misleading. The reality is a mostly empty cosmos dotted with tiny worlds moving in intricate paths around a glowing star. The notion of scale is also mind-bending when we consider travel. Light, the fastest thing in the universe, takes over 8 minutes to reach Earth from the Sun. Jupiter is about 43 minutes away by light. Neptune takes over 4 hours, and the edge of the solar system would require nearly a full year for light to travel. Even spacecraft, like Voyager and New Horizons, take decades to reach these distant worlds. The human experience of distance, shaped by walking, driving, or flying, cannot intuitively grasp the enormity of interplanetary space. When we place all planets on a scale model, something remarkable becomes clear. The emptiness is more significant than the planets themselves. Even the solar system's giant planets are like tiny beads spaced along a nearly infinite string. This emptiness shapes the behavior of the planets, allowing them to orbit without colliding, to maintain complex systems of moons, rings, and even faint planetary atmospheres. Gravity is the invisible architect, sculpting order out of what seems like chaos. The solar system's scale also redefines our perspective on time and formation. Planets form from a swirling disk of gas and dust around the young sun, condensing over millions of years. The distances between them reflect the original distribution of mass, temperature, and angular momentum in the protoplanetary disk. The inner planets, smaller and rocky, form close to the sun where gas could not condense, while the gas giants form far away, accumulating massive envelopes of hydrogen and helium. The tiny rocky bodies, icy moons, and distant Kuiper Belt objects are remnants of this primordial process, each a relic of the early solar system, frozen in time. Even within this vast emptiness, gravity creates complex relationships. Moons orbit planets, rings circle planets, and planets themselves follow elliptical paths around the sun. Asteroids are shepherded into belts, and comets swing inward in long, icy arcs. Magnetic fields stretch across millions of kilometers, shaping solar wind and creating auroras on distant worlds. Scale is not just about distance, but about influence. Objects small in size can exert profound effects over incomprehensible reaches of space. Considering the solar system to scale also forces us to reflect on our own fragility. Earth, the cradle of life, is a mere speck amidst cosmic vastness. Its protective atmosphere, magnetic field, and perfect distance from the sun are conditions that are extraordinarily rare in the universe. Looking outward, we realize that our planetary home is both immense in its capacity to host life and minuscule in the grand cosmic landscape. This perspective encourages humility and wonder, inviting us to explore further, understand deeper, and imagine more boldly. Even the concept of boundaries in the solar system becomes abstract at scale. The heliosphere, a bubble carved by the solar wind extending far beyond Pluto, marks the edge of the sun's direct influence. Voyager 1, humanity's most distant emissary, has crossed this boundary, entering interstellar space, yet it remains within the sun's gravitational domain. Distances are so vast that even the fastest human-made objects take decades to traverse regions that light crosses in hours. Scale transforms time alongside space, showing that exploration is not just a matter of distance, but of patience and endurance. Finally, the solar system at scale is a profound reminder of the universe's grandeur. It challenges our perceptions, stretches our imagination, and inspires both awe and curiosity. From the fiery, radiant sun to the icy, distant edges of the Oort cloud, every object, every orbit, and every empty space contributes to a cosmic symphony that continues to unfold. Visualizing this scale can be mind-blowing, yet it is also deeply enlightening. We begin to understand that space is not a vacuum of nothingness, but a stage for unimaginable dimensions, forces, and interactions. The planets, moons, asteroids, and comets are actors on this stage, performing motions dictated by gravity, energy, and time. Their scale relative to each other and the distances between them is both humbling and exhilarating. In the end, contemplating the solar system to scale reshapes our understanding of reality. It reminds us that our human senses and everyday experiences are insufficient to truly grasp cosmic proportions. It provokes questions about exploration, about life beyond Earth, and about the delicate balance that allows our planet to exist in a vast and mostly empty universe. Each planet, each moon, and even the smallest asteroid is a chapter in a story that spans billions of years and millions of kilometers. The mind struggles to hold the scale, but in doing so, it opens to wonder, curiosity, and an appreciation for the sheer magnitude of the cosmos in which we live. To truly grasp the enormity of the solar system, it helps to imagine traveling outward from the sun, visiting each planet in sequence while keeping the scale intact. Starting with Mercury, the smallest and closest planet to the sun, we find a world scorched by the sun's intense heat. On Mercury, a day lasts longer than a year because of its slow rotation, and the temperature swings are extreme, from searing highs of 430 degrees Celsius during the day to freezing lows of minus 180 degrees Celsius at night. Its surface is pocked with craters from countless collisions with meteoroids over billions of years, revealing a history written in stone and dust. Even in scale models, Mercury is barely visible, a tiny marble next to the basketball-sized sun, emphasizing how minuscule it truly is compared to the star it orbits. Venus comes next, nearly identical in size to Earth, but shrouded in a thick toxic atmosphere that traps heat in an unrelenting greenhouse effect. Its clouds swirl with sulfuric acid, and the surface pressure is crushing, over 90 times that of Earth. Despite its similarities in size, Venus is a world almost unrecognizable to our own planet, a reminder that scale is only one part of understanding planetary diversity. If Earth is a small p in a scale model, Venus is another p nearby, but the environment it holds is hostile, demonstrating that size does not dictate habitability. Earth, our home, is positioned just far enough from the sun to enjoy temperate climates and liquid water. In a scaled-down model, Earth is a tiny bead, yet it supports life with complexity unmatched anywhere else in the solar system. The Moon, Earth's solitary companion, is smaller than Mercury but still large enough to dominate the night sky. Its gravity influences tides and stabilizes Earth's axial tilt, creating seasons and enabling the conditions necessary for ecosystems to flourish. Even this small world, Earth, is just one of countless others orbiting stars across the galaxy, yet it feels immense to the life it supports. Mars, the red planet, is about half the size of Earth and sits further away, its surface dusty and cratered. With the largest volcano in the solar system, Olympus Mons, rising nearly 3 times the height of Mount Everest. The planet's canyons, such as Valle Marineris, stretch thousands of kilometers, making Earth's Grand Canyon seem tiny by comparison. In a scale model, Mars is still a minuscule sphere, and the distance between Earth and Mars would be hundreds of meters. Yet it hosts its own wonders, from dust storms that engulf the entire planet to polar ice caps that shrink and grow with the seasons. Moving outward, we encounter the asteroid belt, a region of rocky and metallic debris lying between Mars and Jupiter. Though these objects are often depicted as tightly packed in movies, in reality, the vast majority of space in the belt is empty. Collisions are rare because the distances are so immense, even when considering thousands of objects. Ceres, the largest object in the belt, is only about 940 kilometers in diameter, tiny compared to the planets, yet significant among asteroids. The asteroid belt serves as a natural boundary between the small, rocky inner planets and the giant gas and ice planets further out. Jupiter, the king of planets, dwarfs all others. Its diameter is more than 11 times that of Earth, and its mass exceeds all other planets combined. The gas giant is a swirling storm of hydrogen and helium, with bands of clouds moving at incredible speeds. Its great red spot is a storm that has raged for centuries, a swirling vortex larger than Earth itself. Jupiter's magnetic field is immense, creating radiation belts that would be lethal to humans, yet its gravity also shields the inner solar system by deflecting comets and asteroids, acting as a cosmic guardian. In scale, Jupiter is a massive ball several meters across, but the distance to Saturn would be hundreds of meters further, highlighting the vast expanses even among the giants. Saturn, famed for its magnificent rings, follows at a great distance. Its rings are composed of ice and rock, ranging from tiny grains to large boulders, all orbiting in delicate harmony. Saturn itself is slightly smaller than Jupiter, but still over 9 times Earth's diameter. Its moons, over 80 in number, include Titan, which has a thick nitrogen-rich atmosphere and lakes of liquid methane, and Enceladus, which shoots geysers of water into space from a hidden ocean beneath its icy crust. The scale is breathtaking. Saturn is a massive planet surrounded by moons, yet even this system is a tiny fraction of the space separating it from Uranus. Uranus and Neptune, the ice giants, inhabit the distant reaches of the solar system. Uranus is unique in that it rotates on its side, possibly due to a colossal collision in its distant past. Its pale blue color comes from methane in its atmosphere, and its faint rings add to its subtle majesty. Neptune, further still, is a deep cobalt blue, home to supersonic winds in the Great Dark Spot, a storm comparable to Jupiter's Great Red Spot. Despite their size, Uranus and Neptune are dwarfed by the distances separating them. Traveling from Saturn to Uranus would span over a kilometer in a scaled model, emphasizing that space between worlds dominates the solar system more than the planets themselves. Beyond Neptune lies the Kuiper Belt, a ring of icy bodies that extends hundreds of millions of kilometers into space. Pluto, once considered the 9th planet, is among these distant objects, small yet full of intriguing features, including mountains of ice, valleys, and a thin atmosphere. Other Kuiper Belt objects, like Haumea and Makemake, are similarly distant and icy, forming a vast, sparsely populated ring. The Kuiper Belt is a testament to the leftover material from the solar system's formation, a frozen relic of a time billions of years ago. Far beyond the Kuiper Belt is the hypothesized Oort cloud, a spherical shell of icy bodies that may stretch halfway to the nearest stars. This region is so distant that the sun would appear as nothing more than a bright star in the sky. Comets originating from the Oort cloud are sent plunging toward the inner solar system by gravitational nudges, becoming spectacular streaks of ice and dust in the night sky. The scale here becomes almost incomprehensible. Even the fastest spacecraft could take tens of thousands of years to reach the outermost edges of this distant cloud. Considering the solar system at scale changes our perspective dramatically. Planets that seem large in photographs become tiny points when measured against the distances separating them. Even the sun, massive and radiant, occupies only a small fraction of space. The emptiness is overwhelming, yet it is precisely this emptiness that allows planets to orbit safely, moons to circle their hosts, and comets to journey without interruption. Space is mostly void, but it is structured by gravity into an elegant cosmic dance. Light itself highlights the vast scale. Sunlight takes about 8 minutes to reach Earth, but takes over 43 minutes to reach Jupiter, more than 4 hours to reach Neptune, and days to reach the Kuiper Belt. Voyager 1, launched in 1977, has traveled farther than any human-made object, yet it is still only just beginning to exit the heliosphere, the sun's magnetic domain. The mind struggles to grasp the enormity of these distances. Traveling between planets is not a trivial matter. Even spacecraft moving at tens of kilometers per second take months or years to traverse distances that seem small on a map, but are immense in reality. Visual models can help. If the sun were a basketball, Earth would be a tiny pea about 26 meters away. Jupiter would be a marble over 140 meters from the sun, and Neptune would be nearly a kilometer distant. The Oort cloud would be so far away that it might be invisible on any reasonable scale. This visualization drives home the truth. Planets are small, distances are vast, and our intuition about the solar system is misleading. Empty space dominates while planetary bodies are minor players on a grand stage. Moons and rings add further intrigue. Jupiter's Galilean moons, Io, Europa, Ganymede, and Callisto, are worlds in their own right, with volcanic activity, subsurface oceans, and surfaces larger than Mercury. Saturn's rings are vast and intricate, extending hundreds of thousands of kilometers but composed of tiny particles. Uranus and Neptune have their own moon systems, each containing frozen and mysterious worlds. Even small moons like Enceladus and Europa can hold oceans beneath their icy crusts, making them key targets in the search for life beyond Earth. Scale reveals that moons can be massive relative to planets, yet remain dwarfed by the distances in the outer solar system. The solar system's scale also emphasizes the role of gravity. Gravity binds planets to the sun, moons to planets, and rings to their parent worlds. It creates orbital resonances, shepherding asteroids and stabilizing moons. Even the tiniest dwarf planet can maintain a moon if conditions are right. Gravity is the invisible hand orchestrating this vast cosmic ballet, ensuring that the system remains orderly over billions of years. Without gravity, the emptiness would be even more extreme, and the intricate dance of planets and moons would collapse. Understanding scale deepens our appreciation of the solar system's history. The inner planets formed in the hot, rocky zone close to the sun, while gas and ice giants accreted farther out. Leftover debris became asteroids, comets, and dwarf planets. The solar system's layout reflects its formation, with smaller planets near the sun, massive giants further away, and vast distances between objects that seem tiny on a human scale. Time, like distance, is vast. These worlds have existed for billions of years, witnessing cosmic events that span scales beyond comprehension. Finally, the solar system to scale teaches perspective. Our home, Earth, is a tiny speck in an almost empty void, yet it hosts life with complexity unimaginable elsewhere in our system. Every planet, moon, and comet is a marvel of physics and chemistry, and each occupies its place in a vast, interconnected system. Understanding scale instills humility, wonder, and a desire to explore, reminding us that the universe is far larger and more intricate than our daily lives suggest. The mind reels at the enormity, yet in this immensity, humanity finds its drive to learn, explore, and understand. To continue appreciating the solar system at scale, it is helpful to imagine a journey outward from the sun, moving planet by planet, moon by moon, along a path where distances and sizes are faithfully represented. Mercury, the innermost planet, is a harsh world, its surface scarred by countless impacts over billions of years. A scaled-down Mercury is almost imperceptible, a tiny bead compared to the basketball-sized sun. Despite its diminutive size, Mercury holds secrets about the formation of rocky planets in the solar environment, a miniature laboratory revealing the earliest days of our cosmic neighborhood. Venus, nearly the same size as Earth, emerges as a nearly identical twin in scale, yet a world of extremes in reality. Thick clouds of sulfuric acid trap heat in an unyielding greenhouse, creating a surface hotter than Mercury, despite being farther from the sun. In a scale model, Venus sits just a few meters beyond Earth, but the differences between these neighboring planets are staggering. These contrasts illustrate that size and distance alone cannot capture the full story of a world. Composition, atmosphere, and history all contribute to its uniqueness. Earth, our home, remains central not just in scale but in significance. A tiny bead in comparison to the sun, it contains oceans, continents, and life, a complexity unparalleled within the solar system. The moon, smaller than Mercury yet a dominant presence in Earth's night sky, orbits as a faithful companion, influencing tides, stabilizing axial tilt, and preserving a record of early impacts. These satellites, often overlooked in scale discussions, are crucial to the dynamics and history of their parent planets. Mars, the red planet, lies farther out, a small sphere surrounded by deserts, volcanoes, and canyons. Olympus Mons, the tallest volcano in the solar system, dwarfs any earthly mountain, yet Mars itself remains tiny in scale. Its two moons, Phobos and Deimos, are mere irregular chunks of rock, yet their orbits and composition provide insights into planetary capture in the early solar system. Traveling between Earth and Mars in a scaled model emphasizes the vast emptiness separating even relatively close planets, a reminder that our intuition about distances is often misleading. The asteroid belt stretches between Mars and Jupiter, a sparse yet intriguing region filled with rocky remnants from the solar system's formation. Despite containing millions of objects, collisions are rare due to enormous distances between them. Ceres, the largest asteroid, is still only 940 kilometers in diameter, but its scale relative to surrounding space underscores how small even the largest asteroids are in the grand scheme. The belt serves as a transitional zone, separating the rocky inner planets from the gas giants, and represents a frozen record of planetary evolution. Jupiter commands attention as the solar system's giant. Its immense size, more than 11 times Earth's diameter, makes it a true behemoth in the planetary lineup. The Great Red Spot, a storm larger than Earth, churns continuously, a vivid demonstration of the planet's dynamic atmosphere. Jupiter's moons are miniature worlds in their own right. Ganymede, the largest, surpasses Mercury in size. Europa, with its icy crust and possible subsurface ocean, could harbor conditions for life. Io's volcanic activity is unmatched in the solar system. The distances between Jupiter's moons may be vast in planetary terms, but each moon's scale relative to Jupiter remains tiny, creating a hierarchy of size within the system. Saturn follows as another gas giant, adorned with its iconic rings composed of billions of icy particles. In a scaled model, Saturn's rings would extend far beyond the planet itself, a thin, delicate structure floating in a mostly empty void. Titan, Saturn's largest moon, is larger than Mercury and hosts a thick atmosphere and liquid methane lakes, a small world of astonishing complexity. Enceladus, smaller yet fascinating, sprays water from subsurface oceans into space, hinting at hidden environments where life might exist. Scale models emphasize how these moons, though significant individually, remain mere dots compared to the vast distances separating the outer planets. The ice giants, Uranus and Neptune, inhabit the distant reaches of the solar system. Uranus, rolling along its orbit on its side, has a subtle blue hue caused by methane in its atmosphere, faint rings, and a family of moons. Neptune, strikingly cobalt, hosts supersonic winds and dynamic storms, including a great dark spot similar to Jupiter's iconic vortex. The distances separating these two planets from Saturn and each other are enormous, reinforcing the idea that space between planets dominates over the size of the planets themselves. Travel in these regions, whether by light, spacecraft, or imagination, requires vast spans of time and energy. Beyond Neptune, the Kuiper Belt stretches outward, home to icy bodies like Pluto, Haumea, and Makemake. These distant worlds are tiny in scale but rich in geological and atmospheric features. Pluto, once classified as a planet, has mountains, valleys, and even a thin atmosphere, demonstrating that even the smallest planetary bodies can be remarkably complex. The Kuiper Belt acts as a frozen archive of the solar system's early days, preserving pristine ice and rock over billions of years. The Oort cloud, though hypothetical, expands the scale to unimaginable proportions. A spherical shell of icy bodies, it may extend tens of thousands of astronomical units from the Sun, forming the boundary between the solar system and interstellar space. Comets originating here travel enormous distances to reach the inner solar system, sometimes taking millions of years to complete a journey. In scale, the Oort cloud dwarfs all planets and even the Kuiper belt, emphasizing that our familiar planetary neighborhood is just a tiny region in a vast cosmic sea. Visualizing the solar system in scale highlights the dominance of empty space. Even the largest planets are but tiny dots compared to the distances separating them. Gravity, however, binds these small worlds together, orchestrating a cosmic dance that maintains order over billions of years. Moons orbit planets, rings encircle giants, and distant comets trace elegant arcs, all within a system governed by the sun's gravitational pull. Space may be mostly void, yet it is alive with motion, interaction, and energy. Hypothetical human journeys illuminate the scale in visceral terms. Traveling to Mars with current technology requires months. Reaching Jupiter or Saturn demands years. Even the fastest spacecraft, moving tens of kilometers per second, takes decades to reach Uranus, Neptune, or the Kuiper belt. Light, the ultimate speed limit, requires minutes to hours to traverse the distances within the inner and outer solar system. The solar system's scale transforms our concept of travel, revealing that even relatively close objects are separated by immense expanses. Understanding scale also affects how we interpret images and models of the solar system. Pictures often compress distances to make planets and moons visible side by side. In reality, if planets were shown to scale with their distances preserved, the sun would dominate the frame. Inner planets would be tiny beads far away, and outer planets might be barely visible, points kilometers distant. The emptiness is not just a backdrop. It defines the structure, motion, and dynamics of the system. The role of gravity becomes even more striking at scale. Jupiter's massive pull deflects asteroids, Saturn's rings are shaped by shepherd moons, and the tiniest moons can stabilize planetary tilts or maintain orbital resonances. Gravity shapes motion, protects inner planets, and allows for the complex interactions we observe across billions of kilometers. Without gravity, planets would drift aimlessly, rings would dissipate, and the solar system as we know it would cease to exist. Scale emphasizes not only distances, but the reach and influence of gravitational forces over these vast expanses. Even comets, often romanticized as shooting stars, highlight the solar system's enormous scale. Originating from the Kuiper belt or Oort cloud, these icy wanderers can travel billions of kilometers, taking centuries or millennia to complete a single orbit. Their tiny size belies the distances they cover. When they approach the inner solar system, sunlight vaporizes ices, forming brilliant tails visible across millions of kilometers. In scale, comets are specks racing through enormous voids, yet they provide crucial information about the solar system's formation and evolution. The solar system also invites contemplation of time. The planets have existed for over 4.5 billion years, witnessing the formation of stars, galaxies, and perhaps even the first life on Earth. Scale encompasses not just space, but the passage of epochs. Geological features, crater impacts, and icy surfaces preserve the history of our system. Viewing the solar system to scale is not only an exercise in spatial understanding, but also an appreciation of temporal depth, revealing the continuity of cosmic processes. Continuing outward, the outermost realms of the solar system push the mind to its limits. Beyond Neptune and the Kuiper belt lies the scattered disk, a population of icy bodies whose orbits are elongated and erratic. These objects, like Eris, Sedna, and other distant dwarf planets, trace paths that can take them hundreds of astronomical units from the sun. In scale, even the largest of these objects, though often comparable to Pluto, are mere specks against the backdrop of emptiness. Their distances stretch our imagination. If the sun is a basketball, these distant worlds could be tens of kilometers away, vanishing into the horizon. Yet even here at the edges of our solar system, gravity holds sway, binding these icy wanderers to the sun's domain over eons. The Oort cloud far beyond is perhaps the most mind-boggling element of scale. Hypothetical yet widely accepted by astronomers, this spherical shell of icy bodies may extend almost halfway to the nearest star, marking the boundary of the sun's gravitational influence. Comets from this realm can take millions of years to complete a single orbit. The Oort cloud is a reminder that the solar system is not merely the familiar 8 planets and their moons, but an immense structure whose farthest reaches brush against interstellar space. At this scale, distances dwarf human experience and technology. Even light, the fastest thing in the universe, would take months or years to traverse the outermost boundaries. Imagine a human journey to these distant realms. Traveling to Mars may take months, to Jupiter or Saturn years, to Uranus and Neptune decades. Reaching the Kuiper Belt is a multi-decade endeavor. Reaching the Oort cloud, it would require patience spanning multiple human lifetimes with current propulsion technology. Light speed, a theoretical limit, would still require weeks or months to travel these distances. Scale transforms not only space but also our perception of time, emphasizing that the solar system is not a collection of objects, but a sprawling arena across which cosmic forces operate. Even in the emptiness between planets, life, or at least conditions for life, may exist in surprising ways. Europa and Enceladus, moons of Jupiter and Saturn, host subsurface oceans beneath icy crusts shielded from the cold vacuum of space. Titan's methane lakes create unique chemistry. In distant Kuiper Belt, objects preserve pristine ices and organics from the birth of the solar system. Scale teaches us that even small worlds can be laboratories of possibility, while vast emptiness can protect and preserve the conditions necessary for these hidden environments. The solar system's scale also magnifies the beauty of orbital mechanics. Planets follow elliptical paths dictated by gravity, moons orbit with precise timing, and ring systems maintain delicate structures through resonance. Even tiny moons like Saturn's Pan, Daphnis, or Neptune's Naiad and Thalassa play vital roles in shaping ring patterns or stabilizing orbits. Distances and sizes must be respected. Moons tiny compared to planets can nonetheless influence vast areas of space, highlighting the interplay of mass, gravity, and motion across immense scales. Rings themselves, delicate and complex, demonstrate scale in microcosm. Saturn's rings, composed of billions of icy particles ranging from dust-sized grains to house-sized boulders, stretch over hundreds of thousands of kilometers, yet the ring thickness is only about a kilometer. Jupiter, Uranus, and Neptune also host rings, smaller and fainter, but each structure adds to the intricacy of the solar system's architecture. Scaling these rings is fascinating. A tiny marble representing Saturn could have a paper-thin sheet encircling it, yet the actual distance across the ring would span kilometers in a human-scale model. Comets illustrate scale in both space and time. Long-period comets originating from the Oort cloud may take millions of years to return after their first journey into the inner solar system. Their tiny nuclei, often just a few kilometers across, become brilliant displays as solar heat sublimates ice into luminous tails stretching millions of kilometers. The contrast between their minuscule size and the length of their tails or orbital paths is striking. Even small objects can traverse enormous distances, acting as messengers from the outermost reaches of the solar system, carrying pristine materials from its earliest days. Thinking about the solar system to scale also provokes philosophical reflection. Earth, our home, is a tiny sphere floating in a vast void, yet it sustains an extraordinary diversity of life. In the grand scheme, humans are almost negligible in size and influence. Yet our curiosity drives us to explore, to imagine and to understand the enormity surrounding us. Space, mostly empty, yet structured with precision, teaches humility and awe. It reminds us that survival, discovery, and comprehension are challenging not only because of scale, but also because of the inherent complexity of cosmic architecture. Even the apparent simplicity of a planetary lineup hides the intricacy of the system. Distances dwarf sizes, gravitational forces orchestrate motion over billions of years, and the tiniest objects, from dust particles to dwarf planets, play essential roles in maintaining cosmic balance. The solar system is not static, it is dynamic, evolving, and incredibly vast. Events like asteroid impacts, comet visits, or the migration of giant planets are reminders that this vast stage is not empty, but alive with motion and change. In imagining the solar system to scale, analogies can help. If the sun is a basketball, Earth is a small bead 26 meters away, Jupiter a marble 140 meters out. Neptune nearly a kilometer distant, and the Oort cloud tens of kilometers away, almost disappearing into the horizon. Distances between worlds far exceed their sizes, emphasizing that planets are islands in an immense ocean of space. Even moons, rings, and comets that seem large in pictures are almost invisible when scaled accurately. The solar system is overwhelmingly empty, yet its architecture is elegant, precise, and awe-inspiring. Finally, contemplating the solar system to scale invites reflection on our future. Space exploration, settlement, and observation will always be constrained by distance. Even with advanced propulsion, interstellar travel remains a monumental challenge. Understanding scale encourages realistic planning, appreciation for the engineering feats required to explore these distances, and an awareness of the limits imposed by the universe. Yet it also inspires wonder, creativity, and perseverance, reminding humanity that exploration is not just about proximity, but understanding, curiosity, and the desire to transcend boundaries. The solar system to scale is a revelation. It transforms our perception, revealing planets as tiny, distances as immense, and gravity as the invisible architect, orchestrating motion across billions of kilometers. Moons, rings, comets, and distant icy bodies demonstrate that even small objects can have profound influence when placed within this vast arena. Light, time, and motion interact over incomprehensible expanses, producing a cosmic system of breathtaking complexity. Earth, while small, is a treasure amidst emptiness, a delicate home in a sprawling cosmic neighborhood. Ultimately, understanding scale instills both humility and awe. It teaches that even the smallest worlds contain secrets, the emptiest spaces are filled with potential, and human curiosity can bridge the gap between the tiny and the vast. The solar system is a masterpiece of proportion, motion, and time, offering endless opportunities for discovery, reflection, and inspiration. From the sun's radiant core to the distant Oort cloud, from mighty Jupiter to icy comets streaking across the void, the solar system reminds us that the universe is infinitely larger than we can imagine, yet inviting us to explore, learn, and marvel at its grandeur.